Okay, so we're reviewing for the quiz on probability that's going to happen tomorrow. It's on sections 12.1 and 12.2. And so far, here's some of the topics we've talked about. Theoretical versus experimental probability is one big important thing for you to understand. All right, I've got cards here. Got the king of spades, I got the jack of hearts, I've got the nine of clubs, I got all four fives, and I got another nine of diamonds. Okay, so I got a total of 4, 5, 6, 7, 8 cards here. All right. Theoretically, what's the chance you're going to get the king of spades if you pick? There's one king of spades, right? Okay, there's a 1 out of 8. All right. What's the probability you're going to get a 5? One half. Okay. Now, as in a 50% chance you're going to get a 5. So, if we try this a few times, pick a card, any card. And he got a 5. All right, so that happened once. Reshuffle them a bit here. So far we're 1 for 1. Okay, pick a card, any card. He's got another 5. 2 for 2. All right, let's shuffle these around a little bit. Okay, pick a card, any card. Another 5. I'm forcing them to choose these cards, yes. No, I'm not cheating. There, it's all random chance. I'm not making them pick the top card or anything. They can pick any of the cards, so, alright. Pick a card, any card. Alright, finally somebody that doesn't get a 5. Okay, so now how many 5s in a row do we have? Alright, now you were suspecting that I was cheating, and I don't blame you, because there's only supposed to be a 50% chance, right? But it was coming up more often than that. So out of 5 times, we got, how many times? Did we do 4 times? Out of 4 times. We had 3 out of 4 of them come up with a 5. All right, so that is doing an experiment. That's experimental probability. So our experimental probability is 3/4, or 75% chance of getting a 5. Do you think it'll stay that way if I keep doing this over and over and over and over and over again? No, if I keep doing it over and over and over and over and over again, and I do it like 1,000 times, it's going to get closer and closer to what percent? 50%. And that's what the law of large numbers is. That if you keep flipping the coin a ton of times, so to speak, you're eventually going to get the theoretical results. So in this case, if we keep doing this experiment, we keep asking kids pick a card, any card, eventually it's going to come around to around 50% if we do a lot of trials. But this is really important. Does that mean that if I get 4 5s in a row, that the next one has an even higher chance that it won't be a 5? No, it does not. It does not mean that. The law of large numbers doesn't mean that if you get a big string of, like, if I'm flipping a coin, if I get a big string of heads all in a row, that the next one has to be tails. Not even higher chance of a tails. It's still a 50-50 chance. All right? So that's important to understand, that the law of large numbers does not save you. So many people are sitting in a casino, and they say, I've lost, and I've lost, and I've lost, and I've lost. I'm due. I'm gonna probably win this time. I'm gonna bet even more now. Do you get the logic? Do you see why they think? They think, I've lost so many times in a row, the law of large numbers means I have to win this next hand. No. In fact, it probably means you're just really bad at playing cards. Or really bad at whatever the thing is. So you're probably gonna lose again. So the point is that you have the same probabilities. The stuff that happened before doesn't affect it. All right. Monte's dilemma. We talked about. I'll talk about this briefly. I have this jack of hearts here. I'm going to hide it under either the 1, the 2, or the 3. If I hide it under one of these spots, okay, where do you guys think it is? 1, 2, or 3? Now, unless you can judge really well by watching my hand hiding it, do you agree that you only have a 1 in 3 chance, or 33% chance of guessing right? All right. Okay, so raise your hand if you think it's under number 1. Raise your hand if you think it's under number 2. Raise your hand if you think it's under number 3. That's the most people. All right, so if you guys are guessing on number 3, and there's a 33% chance that it's under number 3, here's what this game show host Monte Hall would do. Same scenario, except it's like a car. and it's behind a great big door, great big doors. Yeah, you talked about this one in some of the other classes. But yep, it's just like that. Now, if I'm going to tell you, I guarantee you that the card, I'm going to double check where I put it. I'm going to guarantee you that the card is not under number 1. Now, you have a choice. Do you stick with 3 or do you switch to 2? All right. Now, the interesting thing is that my class didn't talk about this. In my class, a lot of them are saying stick, stick, and a lot of people do that. Have you seen stick or have you seen the one with the suitcases? What's that one called? Deal or no deal, yeah. And they're like, they have this feeling that they've got it in their original case that they guessed out of like, I don't know, 30 briefcases. And they think it's probably in the one they picked at the beginning. And they don't want to switch because they feel like that's the lucky case. But is it smarter mathematically to switch? Well, here's a way to think of it. Here's a way to think of it. If I've guaranteed you it's not under number 1, now you know it's either under number 2 or number 3, right? Remember, the probability that it was under number 3, which is what you guessed, on average, the group, the probability it's here is 33% chance. The only 2 places it can be are here and here. So the other one's got to be 66% chance. It's true. It's true. There's a 66% chance it's under the other one. You should switch. But why? All right, let me give you an example. It goes against what a lot of people feel. And even those of you that had seen this example before probably don't know this part. This was run in a newspaper column back when that game show was popular. This lady named Marilyn, she's a genius. She wrote this newspaper column, and people ask her questions because she's a genius. And she'd give them their answer. Because people are always kind of curious what a genius would say about this. All right, well, she said that you should switch. And people had been watching this game show all along, and they had never noticed that if you switched, you were more likely to win. And so they were like, no, it's just the same chance. I mean, if you stick with the original one or you switch, it's the same probabilities. In fact, she got so much mail on this, and a lot of it was like evil mail, like, you know, you're no genius, you're clearly, you know, an idiot or that kind of stuff. She was totally right. Her favorite one was like a professor from some big college who said, "This is why women shouldn't do math." Anyway, and he was totally wrong, and he published his name. Can you imagine how embarrassing that would be for him? Anyway, she was right. You should switch. All right, so in your case, I'm telling you, you had a 33% chance you were right here. You'll have a 66% chance you're going to switch, or that you should win if we switch. So I'm going to make you switch to number 2. And you win. But why? We're going to do it again. There's a 1 in 31 chance if there's 31 cases, yes. If you've eliminated it down to 2 cases left that one of them has the million in it, you should switch, and you have a 29 out of 30% chance that it's in that other case. And everybody that's on the show doesn't know this either, because they're like, oh, I don't know what to do. It's not even a question. You should switch. It's a no-brainer. All right. So now, what do you guys think? Is it under 1, 2, or 3? Who says 1? Raise your hand if you think it's 1. Raise your hand if you think it's 2. Go, how about 3? Ooh, there's a lot of people say 3. All right, we're going with 3. I need a count on this. Who says 1? Raise your hand if you say 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who says 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 3 wins. So you have chosen 3. I'm going to double check here, and I guarantee you it's not under number 1. So what should you do? Should you switch or stick? Switch to 2. And you win again. Isn't that freaky? Try it sometime with your friend and you know, like hide your cell phone under a blanket or something and have them try it. And if they stick, they'll win 33% of the time. And that one, everybody understands that. If you just stick with your original one, you have a 1 in 3 chance. But it's the switching thing that just freaks people out. Okay, so that's an example of when you try an experiment, you might realize that your theoretical was wrong. A lot of people's theoretical thought is that if you switch, you have the same chance as if you stick. And if you try it, an experiment can sometimes tell you that your theory was off. And when you actually try it, you do this a bazillion times, you find out you win 66% of the time if you switch. Yes? All right, so we're moving on. We're talking about sample space now, and that's a list of all possibilities. In your notes, please, would you underline that? A list of all possibilities. Because I know when you get to the test, you're going to see the thing called sample space, and you're going to say, what was that again? I don't remember that. And by making you highlight that, you're more likely to remember it now. I engage that other part of your brain, you're more likely to remember it. Now, if I made you stand upside down, do an upside down handstand, and then look at that, you probably remember it even more, but at some point we have to stop with the ways to make you remember it better. And if there was a violent experience associated with it, you'd remember it even more. So if I could like smack you across the face while you're underlining it, you'd remember sample space. But I don't think they allow me to do that. Oh, okay. All right. Okay, so if we roll a die, there are 36 things that could happen. Do you get that? How come? I thought there's only like 12 numbers that could come up, or you know, like the numbers 2 to 12. How can there be 36 things that could happen when I roll 2 dice? Ah, there's 6 on each die. No, not counting that. So if there's 6 on each die, then I just multiply the possibilities together. There's 6 things that could happen on the blue die, and there's 6 different things that could happen on the red die. And if we make a list of all of them, there would be things like this. I could get a 1 and a 1. I could get a 2 and a 1. I could get a 1 and a 2. If I made a list of all of them, there would be 36 things that could happen. And do you know which one comes up the most? 7. There are lots of combinations that make a 7. All right. So now, independent versus dependent. If I roll a die and I get a 6, and then I roll it again, does the result depend on the first roll? Does this die care what it rolled last time? No. So therefore, rolling a die, is it dependent or independent? All right. So it's independent of what happened the last time. All right. Let's move on. You should flip to this page on your iPad. We are going to be doing a little practice, and from my experience, it's a lot easier to do the multiplications not on the iPad, so you can keep this up and not have to switch apps. So would you right now grab your graphing calculator, take it out, set it next to your iPad, and when I ask you to do the problem, we'll just type in our math on the one and keep the iPad up for notes. If you want to borrow one of mine, make it rapido, por favor. Go ahead. Don't have to even leave me anything, just take it. Anybody else? Anybody else? There you go. Okay. So now we're talking about female high school graduates. Well, we've got all kinds of kids here. In fact, there's 3,172 kids that were polled at that school. At our school, it would be pretty close to that. At our school, it would be about 2,900 students. So this would be comparable if you polled all of the students at Minnetonka High School, for example. But here they polled just men or women off the street, and they found out that a lot of them only had an 8th grade education or less. There's actually a pretty high percentage of kids in the United States who drop out of high school. And we're proud in Minnetonka that we have a very low rate of kids that drop out. But there are cities and schools where you'll have half the kids that go into the school as a freshman quit before they graduate. Like half. Can you even imagine that here? It's not even close to that here. In fact, we have, what was it, 85% or 90% of the kids that we have, 99% of the kids here will go on to some sort of college or will at least graduate. And then another very high percentage of those kids will go on to college, like 85, 90%. So the point is that you might not imagine people having an 8th grade education or less, but it does happen. There's a lot of people out there. All right. These are people that had graduated from high school. How about these people? Did they graduate from high school? Yes, and they had some college. Okay, that'd be like a couple people in my family, a couple of my sisters went to some college, but they didn't get a degree. Then here's bachelor degree, and that's like a 4-year degree. In fact, this could even include 2-year degrees. I've got a brother who's got a 2-year degree, and it was very successful for him. He went on to go fairly high in a company with just a 2-year degree. But he was really good at what he did, and 2-year degrees can work really well for people too. All right, so this one is a graduate degree. That's like, I've got one of those. You go beyond your 4-year degree, and then you get a master's, or you can get a specialist degree, or you can get a doctorate, or you can get a JD. You guys know what that is? Juris Doctor, do you know what that is? Every lawyer you've ever heard of, they're a JD. That's a Juris Doctorate, okay? So lawyers actually have a doctorate, if you didn't know that. Okay, so moving on. If I'm talking about somebody who is a female high school graduate, they picked this random person out of my big group, and they got a female high school graduate. First I have to ask myself, how many of them are there that I could have gotten that were female high school graduates? 232. All right. Now notice this says 8th grade or less. That's why I can't include these guys, right? Because they didn't get to high school to graduate. All right, so I can't choose them. I can choose those. These are what I want. Remember, probability is always what you want over what's possible. I keep coming back to that because as probabilities get more and more complicated, you got to understand the fundamentals. It's what you want on top over what's possible. So type that in and I'm going to see which of you divide by the right thing here. There's a couple different things you could divide by. All right, so what's possible? I'd say the 2 logical things you could possibly use would be those 2. Which of them is right? Raise your hand if you think it's Exhibit A, and raise your hand if you think it's Exhibit B. Who's got A? Who's got B? A lot more people pick B. All right, here's when you would pick A. If I told you ahead of time we were only going to pick from high school graduates, then you should use this. Did I say that? No. I said we're going to pick somebody from this whole group of people, which is this. So this is the one you should have used. So when you take that divided by that, hopefully you get that. Raise your hand if you had .073. All right. If you didn't, hopefully you understand what you did wrong. All right, moving on. Probability of at least some college education, and then it's got this funny looking bar thing, and then it says male. Are you asking a question about the last one?
Yeah.
Okay, I'm going to stop for a second and go back to the last one because I have a question.
Okay, so what is this high school graduate? Could you include people who have been to college too, so they also graduate?
That's a good question. That is a really good question, and in fact, I really don't like this chart because it can get really confusing about which kids to pick from. When they said a female high school graduate, it would be perfectly legitimate to ask the teacher on the test, if there was one like this, do you mean that they could have gone beyond this and gone here, here, or here? Because I think you're right. I think you could have made a really good point, and I would have actually given you credit on the test if you had added up all of these, because you could say, how could you get to be a doctor without having graduated from high school, right? So I would agree. But in this case, my answer came out to .073. I knew that was coming up on the smartboard, so I went that way. But it is kind of you could argue that. And in fact, on one of our next questions, you're going to have to ask me a question like that, or you won't get it right. So feel free next time, say, do you mean this or that? All right. The next one, probability at least some college graduation / male. What does this slash thing mean? Given. If you didn't know that, if you didn't know it was given that it had to be a male, you better take that in your notes and say, that's important. because that changes everything. Given that it's a male means, do you get that these guys aren't even options now? Okay, so would this total be valid anymore then? No. All right, so then we must be talking about just males, so I'm going to circle this and say probability of at least some college education. What I want there is at least some college is here. Would these guys have at least some college? And at least some college here? I want to put all of those together out of the total, which would be right there. So that's going to be, add these up, that plus that plus that. Use your calculator. You've got one. I don't. Got it ready? What'd you get? Well, not the answer. Answer just what's the total to put on top. Did anybody verify 1219? Okay, thank you. And then it's out of 1570. And so I divide those two and I get 0.776. All right. Let's see if they agreed. Oh, yes, they did. See, on that one, we did just what you said, which was we included the other people. Now, why didn't we the first time? I don't know. I'm going to have to talk about whether we should change that on our smartboard for next time. All right. If you understand what's happening here, you'd understand that that's a given question. Try to figure out the answer, and then I'll reveal it in just a second. Is there somebody else? Bit. All right, sorry, got interrupted there. So back to, given it's a high school graduate, I'm hoping that you picked that there's more than just a few high school graduates. See, given it's a high, I know it's going to be tricky. So you should have asked me. Remember, you could ask me on the test. Do you mean that, well, because think about it. Do you think some college, these people, don't you think they had a high school degree? But you should ask. All right, so that's possible, that's possible, that's possible, and that's possible. Or you could take this and subtract that. That's another faster way to do it. You know what I mean? It's all of the people except those 81. So you could take the 3172 minus the 81. But wait, does this say it's only choosing from women? No. It's important you understand that. This is the part that's given. They are a high school graduate. Does it say women over there? No. The second part is the given thing. So it's only picking from the ones I circled in black. Those are the ones that are high school graduates. It doesn't say it's going to be a woman until you look at the what you want part. You want it to be a woman, but we don't know for sure it's going to be. All right, so it's what we want over what's possible. What's possible is adding all of those up, or taking 3172 minus the 81. What did you get for that, by the way? 3091. Thank you. And then what you want on top, which it would be a woman picked out of this group. Okay, so it can only be women is what you want. So that would be, wait a minute, where are the women? I can't see, there we go. These guys, all of those guys would be what you would want. All right, so I could take all of those and add them up, or take 1602 minus 35, and it'd be 1,500 and something. What is it? What? 1560. Thank you. When you divide them, I'm hoping you get 0.432. Did anybody get that exact decimal answer?
Oh, look at him.
All right.
I got that weight, but I just did 3.
Is that not correct? Wait a minute.
Yeah, okay, but
Stop talking. Stop talking. I just need to know whether or not this answer right here comes from this or not.
no.
It does not. Okay.
It comes from, should I say, what
Okay, now you can tell me what you think it comes from.
it comes from 232 divided by 537.
All right. So if we had done this problem another way and done this divided by this, we'd have gotten that. All right. That does that same, again, this is a really bad question because do you get how you could argue these are the high school graduates, so we should pick from them? Do you get how you could argue that? It says right in the chart, high school graduates. But do you get that these guys also are high school graduates? So I think this is wrong. Because I don't think they were thinking about how these guys are high school graduates, so are these guys, so are these guys. They have to be a high school graduate to get a college degree. They don't let you into college without high school. So, all right, so anyway, I get why the teacher did this, and you can see how it can be confusing. But on a normal chart, you don't have that complication. It's going to be like red dogs, blue dogs. Well, there's many blue dogs. There are some, actually. Down south, certain kind of, anyway. It won't be things where you could be high school graduate, plus you're also a college graduate, plus you could also be, it won't be that complicated. All right, let's move on. Look at this one. This is called area model of multiplication. So, area model of probability, actually. We are going to use multiplication. Probability that you land somewhere in the shaded region. What you want is to be in there. 5 times 8 is 40. Why don't I use 40? Divide by 2, and that's 20. Over what's possible, all of this, which would be 12 times 8, which would be 96. 20 over 96. When you divide those two, get a decimal. We'll see if it's what. 0.208. Raise your hand if you had that one right. Okay, good. Moving on. Chance of snow on a given day in February is 0.3. That means like 30% chance. Draw a tree diagram that represents snow on the 6th and 7th of February. That kind of confused me at first because I thought they meant we had to include all the other days before it, but think about it. On the 6th, does it really matter what happened on the 5th? No, these are independent, and therefore I can start my chart for the 6th of February. Would you agree there's only two things that could happen on the 6th of February? It's either going to snow or not. Go ahead, start your chart. And you could put S for snow and N for not, maybe. All right, do you agree that the snow chance is 0.3? Then what's the not chance? 0.7. Now some of you are thinking, but how do I get the next day here? This is the first day, which was on the 6th. And this is our second day. I'm going to make dotted lines here. The first day is here in black. Our second day is over here in blue. If this was about babies, it'd be the second baby being born is over here in the blue column. All right, so now, if it snowed on the first day, now the second day has snow or not. Second day, snow or not. If it snows, 0.3, 0.7, 0.3, 0.7. And now, when it's all said and done, we're going to multiply. 3 times 3 makes 9, but there's 2 decimal places, 0.09. 0.3 times 0.7 gives me 0.21. Same deal here and here gives me 0.21 again. That one's feeling left out, so I'm going to circle him too. For those of you that are, what's that called? Where you have to have everything, like you have to touch. OCD, there we go. Because leaving that one not circled is probably bothering some of you right now. 0.7 times 0.7 is 0.49, so I just leave it that way just to torture you. Circle it. Okay, fine. So now all of these would add up to, what do you think? 100%. But what do I want? Let's say that they asked this question. What's the probability that it snowed exactly 2 days in a row? 0.09. But, Mr. Server, you always said it was what you want divided by what's possible. How could this be that? Well, what you want is this. What was possible was everything. When you add up everything, what does it add up to? 1. So I could divide by 1, but there's really not much point because dividing by 1 gives me the same answer. That's why the answer is just 0.09. All right, let's do one where you are going to have to actually divide. Then I'd say given, as soon as I say given, it changes what it's out of. Given that it snowed the first day, what's the probability it's going to snow both days? It totally changes the answer. It's not 0.09 anymore. Given that it snowed the first day, what's the probability it'll snow 2 days in a row? All right. Because if I give you that it snowed the first day, this is not a 30% chance anymore. What's this? A 100% chance. And you're going to times it by, this is the route we took. I'll use my highlighter. Not that one. That one. There. And then there. And then I multiply 100% times 0.3. It'd be 0.3 or 30% chance. Then. All right, I'm going to change it one last time and see if we can get the right answer. Given, all I know is from my emails I got from my friend that it snowed one of the 2 days. Not the first day. Given that it snowed one of the 2 days, what's the probability that it only snowed one day? Process the question. Given that somebody, listen, somebody emailed me and told me that I knew one of the 2 days it snowed, but I don't know what it did on the other day. What's the probability that it only did snow one day? What do you think I should do? How about this? What does probability oil is boiled down to? What you want over what? Possible. All right. Let's start by figuring out what was possible then. All right, so let me get rid of this. So then you're saying it's possible that I could do this and then this? That is a possibility, right? Because it's got 1 day where it snowed. Is there another possibility? Yes. It could have not snowed and then snowed. Okay, so those are the two that are possible. So those two would go on the bottom. And what did we want to happen? That would only snow 1 day. Is there any other possibility? There's other possibilities you're forgetting. Ooh, we got it in the back. What else is possible? Yes! It could have happened here too. It could have snowed both days. All we knew is that it snowed one. We don't know about the other. Get what I'm saying? We knew that one of the 2 days was snowy. We didn't ever hear anything about the other day. All right, so all of these three things are possible. We'd add up all of these three things. That's what's possible. And then what we wanted is those two. So final answer, 0.42 over 0.51. And if you divide those two, you'll get your final answer.
Wait, so what was
The question again was, we knew it snowed one of the 2 days that she was on their trip, these 2 days. And we don't know about the other day. So what's the probability that it only did snow one and not the other day? So that rules out that it couldn't be that we don't want this one to happen. So we want these two. Out of the total, all of these could have happened. Put it there. All right, remember, it always comes down to what you want or what's possible. All right, on this one. Flip the slide to the next slide, please. Get here, caught up with me. First baby. Let's say, cool, that this is 0.5 and 0.5 chance. 50-50 chance of a boy or a girl. In the real world, it is pretty much that. There's a teeny tiny advantage. There's more likelihood that you will have a girl than a boy. And that's not counting like all in China where there's a lot of pressure to have boys because they only get one child. And if they have a girl, it won't carry on the family's name. And so a lot of people in China, now I'll just say, for some reason, there's a lot more boys in China than girls. So I'll leave it to you to figure out how that happens. Okay. It's true. All right. So what's the probability? We in the United States don't have to worry about this. You can have 3 kids if you want to. You got 0.5 times 0.5 times 0.5 is 0.125. But if I do this route, I'm going to have to do 0.5 times 0.5 times 0.5. Isn't that the exact same thing? So how come all charts aren't this simple? Because if these are the same as each other, then it can be that simple. All the outcomes will be 0.125. But on our last chart, they weren't. It was like 30% chance and 70% chance. Then all the numbers would be different at the end. But in this, they're all the same. But that doesn't mean that the questions are all super simple. Remember, it's what you want over what's possible. Probability of girl, girl, girl. Well, it's right here, 0.125. But technically, we should divide by what's possible. Everything was possible, which would add up to what? 1. So you just take 0.125 divided by 1, which is 0.125. You get that? Okay. Probability of 2 boys. All right. Is anything possible from this statement? Do they make any limits, like it's got to be given that there's a boy or no? So everything's possible, so it's dividing by 1. So we just got to find ones where there are 2 boys. Would this one qualify right here?
Yes.
Yes, there are 2 boys in there. It didn't say exactly 2 boys. There's a difference. There are 2 boys in that family. Are there 2 boys in this family?
Yes.
How about this family?
Yes.
How about this family? Okay, so then I go back and go undo. All right, how about this family? 2 boys? And I think that's it, isn't it? So I just add all of those up, and technically I should divide by 1, but you know, dividing by 1 doesn't do anything, so. All right. Let's do one more challenging one. Actually, let's not. Let's jump into the homework. So that's enough for today. Your quiz is on that kind of stuff. If you need help, all 3 math teachers are available Thursday morning. So if you want to come in and get extra help, I'll be here. You can ask probability questions to your heart's content for the hour before school starts, okay? So from 7 to 8, I'll be here if you want extra help. One more question. I'll see if it pertains. Yeah, it isn't clear. So if this was a test and my grade was on the line, I would have asked me, did you mean exactly 2 boys or at least 2 boys? Because you're right. There's different answers for both of those. All right.